Hi future doctors, welcome to the next class. In this class we'll see some problems of center of mass of different objects whenever they placed along x-axis. So one ring if you are taking, its center of mass will be at center. If you are taking another ring, so where is the position of center of mass they are going to ask. If all masses are same, radius A, B and C. Now, where is the position of center of mass of the system, they will ask. At the time, you have to take like this. Generally, we will take origin, first object. Now, for first object, M1 is going to be M. C1, center of mass is at origin, 0, 0. Otherwise, X1 is going to be 0. X1 is 0. Next, M2 is equal to M. Now, where is C2? C2 is nothing but from C1 to C2, A plus B. So A plus B comma 0. This is x2 comma y. Because along x-axis all y's will become 0. Next, M3 is equal to M. C3. Where is C3 means here? Center of mass of this. What is the distance of this? A plus 2B plus C. Correct? A plus 2B plus C comma 0. This is x3 comma y3. What is our formula? X equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Now substitute in this. What is m1? M into x1 is 0 plus m into x2 is a plus b plus m into x3 is a plus 2b plus divided by 3m. So m will be cancelled among all. Remaining you can simple calculation, that is a plus b plus a plus 2b plus c by 3. So a plus a 2a, b plus 2b 3b plus c by 3. This is the position of center of mass. Next, same like this, they will take two lengths, different lengths of the wires, L1, L2. They may take like this also, L1, L2. L1, L2. That is their wish, how they are going to give. Among all these, we will calculate very simply. So, any diagram you can take. I am taking for one of the diagram. This is x-axis, y-axis. Again, two objects. First object center of mass C1. Second object center of mass is at C2. Now, C1 is at origin. So, x equal to m1 x1 plus m2 x2 by m1 plus m2. Correct? So they may give mass, otherwise they will give which is made up of same material or different material. If they give masses, m, they are going to give. If they give linear density, lambda 1, lambda 2, they will give. Isn't it? Or both are made up of same material means lambdas are going to be same. At the time, how we are going to substitute here? So lambda is equal to m by l. So m is equal to lambda l. So if we substitute differently, lambda, if both are made up of same material, different lengths. Lambda m1 is equal to lambda l1, m2 is equal to lambda l2. What is x1? x1 is origin. What is x2? That is going to be l2 by 2. So if we substitute here, so lambda L1 into 0 plus lambda L2 into L2 by 2 by, so lambda L1 plus lambda L2. So once you got this is 0 means all lambdas will be cancelled. L2 square by 2 by L1 plus L2. So L2 square by 2 into L1 plus L2. This is if both are made up of same material, different lengths. If they give both are having same masses, what you will do? Very simple. X equal to m into 0 plus m into x2 is L2 by 2. Correct? That one will not be changed. x2 is L2 by 2 divided by m plus m 2m. So what you are going to get? So 0, m's will be cancelled. 0 this is, so L2 by 4 you are going to get. Isn't it? L2 by 4 means here somewhere. If both are same masses. So they may give linear density lambda, otherwise equal masses. Like this we are going to do. So this is about two objects we discussed. If they give third object, so third object if they give means how to do. So third object if they give L1, L2, L1. Otherwise all are they have given same length also they may take. So at the time you have to take center of mass of this first object, x-axis, y-axis, center of mass of the second object, center of mass of this third object. So x1 equal to 0, x2 is L2 by 2, x3 is L2. This is at distance L2. Now formula you will substitute. So whether they will give same material or different material. So m1 is lambda L1, m2 is lambda L2, m3 is lambda L3. We will substitute in that equation. This is for three objects. They may give same length. Same length means just L1, L2. You have to equate. Different lengths we did L1, L2, L1. So like this you can calculate. Next we will see two discs R1, R2. Two discs. So they have given it like this. Both are made up of same material. Then find the position of center of mass of these two objects there. At the time x-axis, y-axis. Position of center of mass of this first object C1, this is C2. So for C1, x1 is going to be 0. For C2, x2 is going to be. So from C1, C2, that is going to be R1 plus R2. Now what is mass of M1? So this is disk. Disk will be having area. Otherwise, if thickness is there, volume. So area is there means we will take mass. M1 is equal to sigma A1. So M1 equal to sigma pi R1 square. M2 equal to sigma pi R2 square. Now what is our formula? X equal to M1 x1 plus M2 x2 by M1 plus M2. What is M1? Sigma pi R1 square, x1 is 0. Sigma pi R2 square, x2 is R1 plus R2 divided by sigma pi R1 square plus sigma pi R2 square. What is cancelled here? This is already 0. Sigma pi will be cancelled. So R2 square into R1 plus R2 by R1 square plus R2. This is the center of mass position of the two discs. In place of these discs, they will give spheres R1, R2. So for spheres and this one, what is the small difference means? So for spheres, again x1 is 0, x2 is R1 plus R2. But mass is going to be written, so m is equal to rho v. m1 is equal to rho volume v1, rho 4 third pi R1 cube. M2 rho V2, rho 4 third pi R2 cube, because for spheres volume will be there. If you substitute in this formula, in place of R2 square, you are going to get R2 cube. Directly I am writing R2 cube. So this is R1 plus R2 only. So in place of sigma pi R2 square, you will get rho 4 third pi R2 cube. Therefore, in place of R2 square, you will get R2 cube. This remains same. And in denominator, so sigma pi in place of this rho v1 plus rho v2. Therefore, R1 cube plus R2 cube. So if you remember, for disk square, you can write for spheres cube. That's all. So remaining as it is, isn't it? Like that, you have to remember logically.